welcome back to my channel. Today I have one of the smaller amplifiers made by Rockford Fosgate. It's a Punch 100Z2, which is rated just 25 watts per channel into a 4-ohm load and 50 watts per channel into a 2-ohm load. I already have this amplifier for several years in my collection, but I never dynoed this one, so I thought it's time to make a dyno video. Let's check what this small amplifier is able to put out. The Punch 100Z2 is connected to the dummy load. I checked the idle current and the amp is idling at 0.6 amps. Let's zoom to the scope and check out what this amplifier is able to put out mono 8 ohms. The amplifier is connected mono to an 8 ohm load. That means this value divided by 2 is the output power per channel into a 4 ohm load. This test is continuous output power. Clipping, I go back, clean signal, try to squeeze out a little more, no, oh. I reduce the signal to get out of the clipping. So now we can squeeze out a little more maybe. Increase signal. Oh, clipping. I take this value and the amplifier is pulling 11.4 amps. With an output voltage of 40.8 volts we have an output power of 104 watts. That means we have 52 watts per channel into a 4-ohm load and the amp is rated 25 watts per channel of continuous output power into a 4-ohm load. So it's easily doubling the output power. And now I give full power to check out what the amplifier is pulling out of the power supply. And here we have 11.2 amps, 66% of efficiency. Now I'm trying to get some dynamic power out of the amp. And you can see I have 20 cycles of 1 kilohertz and they are all the same level. I inspect the waveform, it's free of clipping and, also the last cycles should be free of clipping, everything is alright. So we have an output voltage of 42.4 volts, that means we have an output power of 112 watts of dynamic output power mono 8 ohms. So that means we have 56 watts of dynamic power per channel into a 4-ohm load. The dynamic power is a value you can see in the birth sheets of your amplifier. If I take the dynamic power for calculating efficiency, so we have an efficiency of a little more than 70%. Now I have connected a 4-ohm mono load to the amplifier. This value divided by 2 is the output power, 2 ohms per channel, both channels driven of course, and the test is continuous output power. I start to give signal. Oh, clipping back. I take this one. I will take a little lower value because we have a little bit of clipping. That looks better. I have an output voltage of 36 volts and with 36 volts I have a continuous output power of 161 watts into a 4-ohm mono load. That means 80 watts per channel into a 2-ohm load, around 80 watts. And let's have a look what the amplifier is pulling out of the power supply if we drive it to full power at 4 ohms mono. 19.76 amps. With continuous power we have an efficiency of around 60%. That's a dynamic power test, mono 4 ohms. There we have 20 cycles. Free of clipping, all have the same level. We have an output voltage of 37.6 volts. That means we have an output power of 176 watts of dynamic power into a bridged load 4 ohms. And if I calculate the efficiency with dynamic output power, I have an efficiency of 65%. That's a good efficiency. I'm going to try 2 ohms mono dynamic. So let me try to get one shot. All cycles are the same level and we have an output voltage of 30.8 volts. That's around 230 watts, a little more of 230 watts of dynamic output power into a 2 ohm mono load. That means we have 115 watts per channel into a 1 ohm load, both channels driven. A little more of 230 watts mono 2 ohms out of this small amplifier. And if you like this video, please leave a thumb up, write something down below into the comment section, subscribe to my channel and don't forget to hit the bell button to get informed for another video I'm planning in the future. And I'm also on Instagram, join me, #AudioKeller. Thank you very much for watching, see you next time, bye bye.